And I'm going to be going over this problem today. So here we have this data set and we're asked to find the estimates of beta naught, which is the y-intercept, and beta sub 1, which is the slope. And here are the symbols for the estimates. So first thing we're going to do is take this data set and open it in StatCrunch, and then from there we're going to go into Stat menu and then Regression. This is a simple linear regression because we only have one independent and one dependent variable, so only one independent variable of x. So we go in here and we select x for our x variable and y for our y variable, and StatCrunch sets it up pretty well. So we have our null and alternative equal to 0 and not equal to 0 for alternative, so that looks good for that. And then we go ahead and compute it, and so our linear regression equation is right here. So we can pull the y-intercept, that would be this number, and it says round to 3 decimal places, it looks like. So negative 3, I lost it, 0.9 something, negative 3.942. And then the slope, let's take a look at that. The slope is the number in front of x, so, and they're asking for 4 decimal places, so be careful on that. So 2.1744. Okay, that looks good. Now the next thing they're looking for is the standard error, the point estimate for sigma. So, and sigma is the standard deviation, so that would be this number right here, the standard error, 0.7016. 7016. Let's see if that looks good. And then here, assuming the residuals are normally distributed, determine the standard error of the slope. So here, that would be this number right here, the standard error, 0.1692. And then here we're going to assume the residuals are normally distributed and test the null. Here we're testing the slope, that it equals 0 versus that the null, which says it does not equal 0 at the 0.05 level of significance. And we're going to use the p-value approach. So here the p-value tests for this. So again, we're testing slope. And this is the row for slope, it's 0.001, so it's kind of cutting off. So let me put that in here, 0.001, that looks good. And then we're asked to make a statement regarding the null and draw a conclusion. So here, we know this is way down in the tail. It's way past 0.05. This is way smaller, and so we would reject. So let's see, reject the null. There is sufficient evidence at the 0.05 level of significance to conclude that a linear relation exists. So I'm going to choose that and see what, perfect. So that's it. Thanks so much for watching, and let me know if you have any questions.